simplify to a single power of 2. Okay, so as an introduction, the larger number, and you probably want to write this down somewhere, this is called your base. And the little number, this is called your exponent or power. I guess my penmanship could have been a little bit better. So this is your base, this is your exponent. Okay, without further ado, let's show you how you're going to do this one. So when you have the same base, and then the operation between the bases is multiplication, all you're going to do is you're actually going to add the powers together. So I'm going to rewrite 2. Again, notice common base, base 2, base 2. And what we're going to do is we're going to actually add these exponents together. So there's 4, and I will add to the number 4 the number 2. So step number 1, write the original problem, 2 to the power 4 times 2 to the power 2. Step number 2, write the common base, 2, and we're going to add these exponents together, so 4 plus 2. And then our final step is we're just going to add them together. Well, what is 4 plus 2? And that is 6. So we're going to go ahead and box 2 root 6. All right, let's try another one. And so this one isn't tricky, but it's kind of like when you have algebra and you had an equation and you had x. What's the number in front of x if you don't see it? And if you said 1, good job. You have these magical numbers that sometimes aren't there, but it's assumed or it's common knowledge that it is there. So in the case where you have, let me back up, where you have a base and there's no exponent there, guess which number you can put there? And if you said 1, you got that. So let's start out by giving this base 6, let's give it a 1. So it has an exponent of 1 there. So 6 to the power of 1 multiplied by 6 to the power of 6. We do have the same base. The operation is multiplication. So let's write base 6. And now let's add the numbers together, but let's show the step. I want you to show me it. So write 1 plus 6. So again, write the original problem, either 6 or 6 to the power of 1 times 6 to the power of 6. Write the common base, then show the addition between the powers or exponents. And that's going to simplify as 6 to the power of 7. And we'll box that. That's pretty much it. Okay, let's go on to the case where instead of multiplying, we're actually dividing here. So if we back up, now notice that when we were multiplying, we added. So what is the inverse to multiply? Well, that's divide. So guess what you're going to do between common bases? You're actually going to subtract the exponent. So start with the original problem. So you got 6, base 6, exponent 7, divided by base 6, exponent or power 3. So let's go ahead and write the original base. So I've got 6, the original power on top is a 7. And just like we said, we're actually not multiplying, we're dividing, so we will subtract the power. So I'm going to do 7, subtract 3, like that. So I got common base 6, and then my exponent or power, I'm doing 7 minus 3. And what's 7 minus 3? And that is 4. So I'm going to write 6 power 4, and we'll box that. Again, start with the original problem, show the operation between the exponents, and then simplify and box your final answer. Similarly, we have 2 to the power of 5, divide by 2 to the power of, and it looks like it's nothing, but again, remember when we did our first example, when we had 6 by itself, we said it had a power exponent of 1, and we added the 1. I would always suggest you do that so you don't avoid silly mistakes. So let's come back over here, and let's give this base 2 an exponent or power of 1. So it's really 2 to the power of 5, divide by 2 to the power of 1. When we're dividing and we have the same base, we're going to keep that same base, but we will subtract these exponents or powers. So I will write 2 to the 5, subtract 1. Okay, so we have our common base of 2, and then 5 minus 1 is 4. So 2 to the power of 4. Our last one that we're doing, this is called power of a power. That means we have a power inside and a power outside. And when you have a power on the inside and outside, you're actually just going to multiply these exponents together. So start with the original problem. Make sure that you've got parentheses, 5 to the power of 3, close parentheses, and then you've got a power exponent on those parentheses. So we're going to write our common base, and just like I said, what did we do between the powers? We'll multiply them. So I'm going to put 3 multiplied by 4. So base 5, 3 times 4, would simplify to base 5, or 5, to the power or exponent of 12. Okay, power inside, power outside. What do? Just like we did over here, we went 3 times 4. We're going to go 5 times 3. So I'm going to write my common base of 4, and then I'm going to go 5, that's the power on the inside, multiplied by 3, the power on the outside, and that will simplify as 4 to the power of 15. And we'll box that. And that's the lesson. Thanks for taking time to view, and thank you for carefully following the steps. Just by way of summary, you've got 3 steps. 1, write the original problem, show the operation between the power exponents, and then simplify. Again, write the original problem, show the operation between the exponents, simplify, and box. Thanks for listening, and thanks for showing your work carefully.